And let me share the screen. Okay, so long-term debt is a future sacrifice, and they contain covenants or restrictions for the borrower. So if for example, if the borrower uses the money to buy a car, they might have a restriction where you can't drive the car over 5,000 miles a month. I'm just making that up. But that's what a covenant or a restriction is. And the indenture or agreement incorporates the terms of the issues and the restrictions. So the indenture or agreement is the contract associated with the bond. So these are, in general, the types of long-term liabilities that you have. So you have bonds payable, long-time notes payable, and then we want to look at reporting and analyzing long-term debt. So with a bond, you can sell that bond like you do a stocks and bonds. Long-term notes payable, you can't sell those. Those apply to your business only. So here then, let's look at some of the characteristics of long-term debt. Long-term debt has a life of 12 years, or I'm sorry, 12 months or more. So it's greater than a year. And on the balance sheet, they're classified as non-current or long-term liabilities. Okay, I really don't see that term non-current too much, but they're classified as long-term liabilities. And some of the types of long-term debt: bonds, bank debt, mortgage, debentures. Bonds and debentures are basically the same thing. Notes payable generally are mortgages. They could be for like a car or equipment also. All right? And some of the benefits, probably one of the biggest benefits of using long-term debt is that the interest expense is deductible for tax purposes. Dividends on stock are not deductible. So that because the interest expense is deductible, that brings down the cost for a business. So in general, what are, again, we're bringing this up again, and here's one more now. So what are the types of long-term debt? Notes payable, bonds payable, and here's the third one I hadn't talked about before: leases. So leases generally are, and if they're a capitalized lease or a capital lease, then it's going to be long-term debt on the balance sheet. Long-term debt has a maturity greater than 1 year. Short-term debt or current liabilities have a maturity less than 1 year. So that's the difference between long-term debt and short-term debt. How long does it take for the debt to mature? Current portions of long-term debt. So you may have long-term debt. It was long-term debt for a long time, but because it's at the very end, now it's due, let's say within 6 months. So even though it was officially long-term debt, because it's due, within a year, it transitions to a current liability. So a bond is a issuer's written promise to pay an amount identified as the par value of the bond and interest at a stated annual, and that stated annual is what's called the coupon rate of a bond. A coupon rate is a percentage of the par value of a bond. A bond is an agreement in which an issuer is required to repay to the investor the amount borrowed plus interest over a specified period of time. So principal borrowed by governments, corporations, from the investor. The government or the investor, the government or the corporation will make regular interest payments to the investor, and the principal is returned to the investor. What is a debenture? Now, many times when you have bonds payable, like for example, the bond might be financing a building or equipment, so on and so forth. That building or equipment is collateral to the bond. In a debenture, there's no collateral. So the difference between a bond and a debenture, or some bonds, and let's say a first mortgage bond, is that you have mortgage as collateral for the bond. In a debenture, there's no collateral. And only firms with very strong financial reputations can issue debentures. Most of the time, smaller, less reputable companies can issue debentures. So only the companies that have a strong financial reputation. So these are bond ratings. So you've heard of bond ratings before: AAA, AA, single A, triple B, and then double B and below. So you see the line between triple B and double B. So triple B, so AAA, AA, A, BBB, triple B, those are called investment grade bonds. Those are called investment grade bonds. Junk bonds, you've heard that term before. Junk bonds are double B and below. Junk bonds are double B and below. Now, how do we determine the value of the bond? So this is like problem 6-11. So the value of the bond is the present value of future interest payments and the par value or maturity value discounted as at the bond's required rate of return. The required rate of return is the yield to maturity for the bond. And the symbol to show that is RD. The return on debt is the yield to maturity. The yield to maturity is the interest rate that you will use to determine the value of a bond. So again, we have here, the reason why I picked this one, it's a little bit better, because we have Y, the interest rate, yield to maturity. And how do they, right here, up here we had annual interest payments, but how does this formula calculate those annual interest payments? The principal or face value or par value multiplied by the coupon rate. So for example, if the bond has a par value equal to 1,000 and the coupon interest rate is equal to 10%, then each year this bond will make interest payments of 10% times 1,000, and that's going to be equal to $100 per year of annual interest expense. It'll be the same throughout the life of the bond. So in this example, we have a bond that has a par value equal to 1,000. The coupon interest rate is 4%, and the yield to maturity, the coupon interest rate is 4%. The yield to maturity is also 4%. So when you work out the math, the value of the bond is $1,000. Now, everything in the numerator here will not change. Everything in the numerator here will not change. So if the yield to maturity is 5%, again, the numerator is the same, but now we're going to put 5% down here. And if the yield to maturity is 5%, the value of the bond is $964.54. So the investor will pay $964.54, will receive 40, 40, 40, and 1,040. All of this, based off this price, all of this is equivalent to a 5% rate of return. Okay. Again, 40, 40, 40, and 1040. If the yield to maturity is 3%, the investor will pay today $1,037.17. All of this that the investor receives is equivalent to a 3% rate of return. Is equivalent to a 3% rate of return. Okay, any questions? Any questions? Now, the next topic that we would like to discuss is bond duration. And bond duration is a measure of risk. And what is the big factor that determines the value of the bond? Interest rates. So what bond duration will do is to measure how sensitive the bond value is to changes in interest rates. So it's measured in units of time. So when we calculate the bond duration, we're going to get 10 years, 5 years, so on and so forth. This unit of time that we measure is always going to be less than or equal to the bond's maturity, because the value of more distant cash flows is more sensitive to the interest rate. The lower the bond duration, the less risky the bond is. And there's a couple different ways to calculate bond duration. We want to focus on Macaulay duration. So just to give you an idea right here, what is duration? Duration is kind of a break-even point, or it's like the halfway point. We have a bond here that has a maturity date. It will have a 5-year life. But what is the break-even? What is the break-even? In this picture, it's 3 years. It's 3 years. The lower this duration, the less risky the bond is. The lower the duration, the less risky the bond is. Okay, so here we go, the last one here. Okay, so let's look at this and let's go over this spreadsheet slowly to see how you go out there and calculate the duration of a bond. So we have a par value equal to 100. The coupon interest rate is 4.25%. The yield to maturity is 5 years. I'm sorry, the years to maturity is 5 years, and the yield to maturity is 4.33. Now, this is going to go out there, and this assumes that the interest rates are paid every half year. Every half year. So where does this 2.125 come from? Again, it's equal to 4.25. So let me put this over here. This is equal to 4.25 divided by 2. 4.25 divided by 2, and that gives us the 2.125. So every year, the investor will receive $4.25 or $2.125 twice a year. So does everyone see where we get these cash flows from? Where we get these cash flows? And in the final year, in the second half of the final year, how much will the investor receive? The par value plus the interest rate. The par value plus the interest rate. Any questions about any of the numbers here? Okay. So we have the present value factor here. The present value factor. Now again, we have to go out there and make a half-year adjustment. All right, and so the yield is 4.33%. So let me put that over here. So that's going to be, the yield is 0.0433 divided by 2. So it's 4.33% per year, or 2.165% every half year. Now, let's do the present value factor, and let's do it for a half year right here. So this is going to be equal to 1 divided by 1 plus the 2.165%. And in the first half year, that's going to be raised to the half power. Raised to the half power. So does everyone see where those numbers are coming from? Any questions? Hit enter. Oh, let's see, I got this a little bit different. I'm sorry. let's use their formula there. So this one's going to be then equals left parentheses 1 divided by 1 plus, let's put another parentheses there, the rate of 0.0433 divided by 200, and all of this raised to the time. So this is first one is 1 year divided by 0.05. Oh, I'm still getting this wrong here. Let's see, I'm typing something in. Oh, let me do this as 5. Yeah, there we go. So still a little bit off here, but that's okay. So I'm just using this formula here. Okay, so here we have the present value factors. All right, so now this column, 2.125 times the present value factor is equal to 2.080. In this year, 2.125 divided by 0.958 is equal to 2.036. So right here then, they have this as this column is equal to column F times column E. I think this is a mistake right here. This should be F times column F times column E, not column C. Column C is way over here. So make a note, this should be column F times column C. So this times this gives you this. This times this gives you this. Questions? All right. So in this case then, we're going to add all of these. We're going to add all of these. The value of the bond is $99.644. $99.644. The par value of the bond is 1,000, but the value or price of the bond is $99.644. Does anyone have any questions? Does anyone have any questions? Okay. Now, this column is going to be equal to time times the present value. 0.5 times 2.08. This is going to be equal to 1.04. 1 times 2.036. So this is probably really what it is when we take it out to more decimal points. 1 times this gives you this. 1.5 times this gives you this. 2 times this gives you this. Any questions on that? Any questions? So we're going to do this all the way down so that the last number the last number in this is going to be 5 times 82.435 is equal to 412. All right? And we add this up, and this is going to give us the time-weighted value. The time-weighted value. All right? The duration of the bond is going to be equal to 453 divided by 99. 453 divided by 99, and the duration of this bond is 4.55 years. So again, the 4.55 years is kind of like a break even. It's kind of like a break even. So in this particular case, how long as a bond investor will it take for you to break even? 4.55. And that's going to take into account the time value of money. That's going to take into account the time value of money. Okay? So let's try this again. And I'll go step by step now. But here we assume that the cash flows were paid on a semi-annual basis, twice a year. Twice a year. Let's assume that the cash flows will only occur now once a year. Once a year. Let me make this a little bit smaller. Okay, so we have the time, cash flow, PV factor, present value of cash flow, and time weighted. So this bond is going to last for 5 years. The cash flow, now that's going to be 0.0425 times the par value of 100. $4.25 every year. In the last year, you're going to receive the $4.25 plus the par value. The present value factor and the yield is 4.33%. So this is going to be equal to 1 divided by 1 plus the 0.0433, that's in decimal notation, raised to the year. Take this all the way down. Column N here is going to be equal to column L times column M. So when we add this up, this is the price of the bond. $99.6471. You see, it's a little bit different. A little bit different now. when you receive the cash once a year versus every 6 months. The time weight is going to be 1 times 4.07, 2 times 3.09, so I want to sum these up. So a little bit different here, a little bit different. And the bond duration now that's going to be 459 divided by 99. $4.60 years, so it's going to take longer. So what does this tell you? It's better if you receive the payments 2.125 twice a year than if you receive 4.25 once a year. When you only receive the interest payments once a year, the bond becomes more risky. The bond becomes more risky. So in this case, and let's put a label here, interest payments, let's call this annual interest payments. So annual interest payments. So for the same bond, if the difference is between receiving the payments twice a year or once a year, you want to receive it twice a year. It's less risky. It's less risky because you're going to receive more money up front. And the more you can receive the money up front, the less risk there is. The less risk there is. So this one, make a note, is on a semi-annual basis. This one is on an annual basis. All other things being equal, semi-annual basis is less risky than an annual basis. All other things being equal, semi-annual is less risky than annual basis. All right, and in both cases here, you could see that the bond price, it's only off by not even a penny. But if this was not $100, but a big amount, the bond price would be different based off the semi-annual versus annual payments. Okay, so in your homework problems, you have a duration problem, and here now you have 2 examples. One is done on a semi-annual basis, one is done on an annual basis. Okay, so any questions? So we don't have much time, we only got about 2 minutes. Does anyone have any questions? Does anyone have any questions? You may have to go back and look at this spreadsheet and determine